So, today's lesson, we're going to start the section on right-angled triangles. Again, this is a small internal that we'll be doing, and we'll get it out of the way, and then we can go back to revision. So, for right-angled triangles, we're going to use some different properties depending on what it is we're looking for. If we're looking for sides, we're looking for angles, we're looking for whatever. So, you're going to use different processes depending on the information you're looking for. Okay, so we're going to be using Pythagoras theorem to find the length of a missing side. So a squared plus b squared equals c squared. And your only issue is to make sure that you're using the right letter to get the right part. Now, the two arms of the triangle, or these straight sides here, those are a and b. And since they're both arms, they're completely interchangeable. But the hypotenuse, the longest side, this longest slanted side, has to be C. So C must be the hypotenuse, which simply means that longest side. Okay? Can't be any other side. If you mix those up, you're going to get in trouble. Now, A and B, you can do any one of those sides for A and B. It makes no difference at all. And all you're going to do is plug it into the formula, making sure that you always use brackets, okay? And then do the algebra. So this is going to help you to help you solve some equations, because you're going to have all kinds of quadratic equations come out of this. Most of the time they're going to be linear, but occasionally they'll be quadratic. So this will help your review a little bit as well. Okay? So let's talk about the steps. First, you're going to label A, B, and C. Be careful about which one you put where. Then you're simply going to substitute into the formula. Okay? And remember, when you substitute, always use brackets. Don't ever put a number in place of a letter without putting it in brackets. It will cause you no end of trouble. Third step is simply to solve the equation. And again, you can end up with, most of the time these are going to be linear, but you could end up with a quadratic equation, so you have to be prepared for that, right? Really look at the equation that you have, okay? And if it is quadratic, you're always going to reject the negative answer. Because remember, what we're looking for here are the lengths of sides, and the length can never be negative. Okay? And finally, use that information to answer the question and don't forget your units. Okay? So I'm going to pause the recording for a minute to let you write all that down. Okay. On the subject of units, watch out for units when you're labeling up here, because the units must be the same. So you may have to convert some units before you do the math. For example, one of the sides may be given as meters and the other one may be given as centimeters, and you cannot mix the units when you're working with these. So be careful and really read the question carefully when you're working through these, because they will trick you with mismatched units. And we'll talk about converting units in just a moment. Now, I have two huge pet peeves about the way this is taught in New Zealand and the way the book does it, and the way you probably learned it. My first one is converting the units back and forth. And because they try to get you to remember that you're either going to multiply by 100 or divide by 1,000, whatever, it just makes it so complicated. So the first thing I'm going to do is talk about converting units by just jumping, which means then you're able to just move the decimal point back and forth. Okay, so let's talk about converting units for just a moment. Now we're dealing with units of length for all of these. So the basic unit of length is the meter. If you go to the right, things get smaller. You have a decimeter, and then a centimeter, and then a millimeter. Now, deci is not used very often. Most often you use centi and milli and meters. But in this particular method that I'm going to show you, you need to know all the measures. Now, as you move to the left, things are going to get bigger. And here, you have deca, then hecto, then kilo. Now again, hecto and deca, who cares? We never use those. We usually just go straight to kilometers, right? But again, in this method, you need to know them all. You need to know how many there are. And what you can do to convert units is simply jump. And each jump is 1 decimal place. So you don't have to memorize all of that. You know, when do I multiply by 1,000? When do I divide by 1,000? Whatever. Okay? And it's in the same direction. As the jump. So all you have to do is simply move the decimal place. So for example, if I have 6 kilometers and I want to convert that to meters, right? All I have to do is know that the number is going to stay the same, but I'm going to move the decimal. So from kilometers to meters, that means 1, 2, 3 jumps to the right. So the decimal is there. So that's 1, 2, 3 new decimal places, which of course means 6,000 meters. Now that one's not so bad because kilo to meters, you always multiply by 1,000. But it's just easier to jump, in my opinion. Now don't change if you already know what you're doing. Who cares? But if you don't, then this is an easy method. Say you're going from millimeters to meters, and you have 70 millimeters. So millimeters to meters. You're jumping in the other direction. You're going left this time. So the decimal is there. So 1, 2, 3 decimal places to the left gives you 0.070, and we, of course, don't need that last 0, meters. So a super easy way to do it. Now, the only problem is you have to remember these guys that we don't use very often. But I think it'd be easier to remember that those places are there than it is to remember when you multiply by 100 or divide by 1,000 or whatever. Okay? And to prove my point, we're going to jump to the book for just a moment. Sorry, pushing too many buttons. So here's what it looks like, the usual conversion table. So fun. So sometimes you multiply by 100, sometimes you multiply by 10, sometimes you multiply by 1,000, sometimes you divide by 1,000, blah, blah, blah. Ugh, I hate it. Anyway, if you use this and you know it, and because you're so familiar with it, because you've seen it for years, by all means, use it. I don't care, okay? But it's pretty ugly, okay? So you'll see that there are some conversion ones in the first exercise set, and you can go through this if you want to. You don't have to. I'm not going to assign it, but if you want to practice a few of these conversions, that wouldn't be a bad deal, okay? Later when we talk about area, we'll talk about the conversions for area, but right now you're just talking about converting lengths. So if you want to see those, okay? Now, my second pet peeve, I usually don't get so excited about these things, but is that they give you two different ways of of looking at this, one for when you're looking for the shorter sides, one for when you're looking for the longer side. You're using the same formula for both. So just solve the equation. I'm not even going to give you exercises where you're looking at it in two different ways. Let me show you real quickly in the book what I mean there. And I'm sure you're familiar with it. You don't need two different ways to do it. You have one formula that does it all. And you're just going to solve the equation, okay? So it doesn't matter if you're finding the length of the hypotenuse or if you're finding the lengths of the short sides. Do the same thing. It makes it a little weird. Now, the only reason they do this like this is because then you can use your calculator, but you can still use your calculator. And beyond that, this will help you study for the MCAT. If you would not use your calculator, well, you can use your calculator for the math because they're going to give you huge numbers because they assume you're using a calculator. But if you just get used to doing it, then when you're working with these on the MCAT, they'll have equations that are similar, then you'll be prepared for that when you're not using the calculator. So let's just go to the mixing it up problem so you can see what I mean. Doesn't matter which one you're looking for, it always works. So finding the missing sides of the triangles, that means use the Pythagorean formula or theorem. It's the theorem is the idea. When you start using it, that's why it's called formula. So let's just look at the first one. So the first step is to label my A, B, and C. And again, A and B are interchangeable. So I'll just call that one A and that one B. But because this is the long slanted side, the hypotenuse, it has to be C. Okay? So then I know my formula is A squared plus B squared equals C squared. Don't forget those squares. So I'm just going to plug in the information I know. A is 25, so 25 squared, plus B is 23, so 23 squared, equals, I don't know C, and they've called it X, so I'm going to use X squared. Now, if you use C squared, it's perfectly fine. Nobody's going to call you down on it, okay? But when you answer this, they want you to say X equals. So go ahead and use the letters they have, but if you revert to C and I'm grading it, I don't care. Okay, remember this is an internal. Okay, so all we're going to do is do the math. So anybody get a calculator handy? Because I don't. So we're going to take 25 and square it. Oops, I'm sorry. I told you don't put them in without brackets, and I just put them in without brackets. So 25 squared. Somebody want to tell me what that equals?
625.
Thank you very much. Plus 23 squared.
529.
529. And that equals X squared. Now we just need to add those two together. So 625 plus 529 is?
1,154.
Thank you. Equals X squared. Now, this is a quadratic equation, but it's a really simple one to solve because all I need to do is unsquare that. Get rid of the square. And to unsquare something, you just take the square root of it. But remember, if I take the square root of one side, I have to take the square root of the other side. So I'm going to take the square root of both sides. And so the square root of 1154, someone, please.
33 point. It says 97, but do you just make that 34?
So 97? Okay. Well, they don't really tell you what to round to, so I would go ahead. If it says 33.97, I would just leave it as 33.97, or you could write about 34, okay? But don't write equals 34. Use the little squiggly about 34. And, of course, these were all in meters, so we need to put our units at the end. Okay? Most of the time, if these are whole numbers, we can feel safe rounding to a whole number. See down here, they're going to give you decimal ones. This one has one decimal place, so we can feel safe rounding to one decimal place. Here we have two decimal places, so we'd round it to two decimal places. Okay? All right. Now, so just do all the math on one side, get the square by itself by just squaring it. Now, technically, when you take the square root of this, you're going to get plus and minus. Remember that? But we were going to reject the minus anyway, so we can use what's called the principal or positive root. So we don't have to write the plus and minus business. Okay? So hopefully that looks familiar. Let's look at one where you're looking for the sides. Okay, so just drop down to number 3. It's good. So here, again, I'm going to label these. So if I call this one B and this one C, this one's my A. And this time I know the hypotenuse, I know one side, so I'm looking for the missing side. Still the same formula. Just plug in what you know. We don't know how long A is, so we'll call it X and square it, plus our 5.9 and square it, and our C is 11.2, and we're going to square that. Again, it's the same formula, the same exact idea as the other one. So X squared we don't know, we can't change, plus 5.9 quantity squared. Anybody? Somebody please?
34.81.
Okay, and here we don't want to round. You never round until you get to your answer, if you're going to round at all. Equals 11.2 quantity squared, please.
125.44.
Okay, now our X is not by itself, but we can get it by itself by simply moving this 34.81. So we'll just subtract it from both sides. So you see that's reinforcing your equation solving skills, which gives you X squared equals, what's 125.44 minus 34.81, please?
90.63.
There you go. And now we just need to unsquare the X. And to unsquare the X, we simply use a radical, a square root. So that gives me X equals, and I only want the positive or principal square root, so I don't need the plus or minus. The square root of 90.63, and since we started off with 1 decimal place, let's have that answer rounded to 1.
9.5.
9.5. There you go, and make sure you put your centimeters in there, your units. Okay, so don't think of it as two different processes. It's the same formula, and you're just going to solve the equation, no matter if you're looking for the hypotenuse or the A or the B, who cares? Okay? Don't let them make you think that it's two different things when it's really just one. All right? Now, nothing's going to change from there. They're just going to be looking for either hypotenuse or sides. Doesn't matter if they turn the triangles on their sides. They're still right triangles. You're still looking for the sides. So we're going to practice some of these. Now, look at this one. This diagram shows an isosceles triangle that's split into two smaller. Calculate the height. So we're looking for this. Well, that's just so if you use this particular side triangle, so you just have to take it apart. If that's half, that means that that's 8 meters and that's 8 meters. We know, so we'll use this side because we know 8 meters is our A, 15 centimeters is our C. So what we're looking for there is our B, our height. And since the height's going to be the same for both of them, you won't have to do it twice. Just find the B, and that'll tell you the height. Okay? So they'll give you all the information that you need to be able to break these apart. Okay? Now, when you're looking at missing sides, just same exact thing. If this wall is 1.5 and this is 0.8, that's your A down there, that's your B up here, or vice versa, who cares? And we know that the ladder is slanted, therefore that makes that your C. Okay? Same thing, ladder, I don't know why I keep saying lantern. The ladder is the slanted part. Okay? Here's a trapezium. We want this length right here. Well, what we can do is draw a new line and turn it into a right triangle. And if it's 8 centimeters high there, it's 8 centimeters high there, right? And if this is 8, and this whole thing is 11, then 11 minus 8 would give you that little bit, right? So cut the square off and turn that into a triangle. You're going to see that quite a lot. Right? Here again, just cut up the shape. You don't know what it is. Remember that when you have these lines, that if the two lines mean that those two sides are equal, these lines mean those two sides are equal. So think about what that does. They're going to give you less and less information, but there you go. Okay, so again, hopefully this is not new to you, and even if it is, it's very, very simple. So what you're going to do is you're going to look at, starting on, what is that, page 15? So on page 15, just go, I think it's 1 through 7. It's when you get to the applications. There's a lot of different pieces. Well, wait a minute. Hold on. A lot of different pieces. Let's see. On some of them. Oh, 1 through 7 on there. And then they start over with the applications and do 1 through 7. So do page 15 through 18. Now, you don't need to do them all, but do make sure that you do a good sample of all of them, and you might want to do all of the applications, okay? But do a good sample. And you just pick the ones that look interesting to you. Make sure you get some where you're looking for the hypotenuse and some where you're looking for the sides. Okay? Now, again, you can go back and look at those conversions as well if you if you're at all shaky on that. So far, all the ones we've had have had matching units, but again, that's not always going to be the case. That's how they're going to push it forward a little bit for you and change those units.